All right. Hey guys, I'll demo the thing I was trying to share. So basically, we've created I'll let Denz. Okay, so first of all, I want to introduce myself. Those of you guys who haven't met me. My name is Nick. Um, I am a co-founder at a project called ArgueFlow. We're basically trying to make software for business teams have better debates is like the long-term goal. A part of that, like really wanted to use embeddings and stuff like that to kind of handle that whole workflow. We built this product, which I'm going to demo, called ArgueFlow Vault. Vault is basically a repository of argument evidence. It doesn't handle mapping, it doesn't handle like claims, it doesn't handle like impacts or any kind of like dialogue. It just handles storing and querying for evidence. To demo it, but the short explanation is that it is a semantic search engine and a full text search engine. And yeah, and Denz is also here from our team. We're a 4-person team, but Denz and I came today, so I'll let Denz introduce himself too before I demo.
Hi, yeah. My name is Denz. I'm another person on the ArgueFlow team. So yeah, basically, as Nick explained, we're like a pretty small team. We're working on ArgueFlow Vault as well as like software for business teams to develop debates. Vault, we hope to be like a component of that, and we hope that Vault becomes like a standard for research and being able to create evidence on there and query it in an open source manner where you can share collections and other things on Vault.
Yeah, so I will go ahead and, I've been screen sharing the whole time. Forgive me for that. Okay, so let me reshare. I have no idea what I was sharing. Okay. Yeah, okay, so like here is the, I guess like thing. Okay, it's like, I guess the first core feature is like, what exactly constitutes a piece of evidence for us? And I'll demo this evidence card based on AI. Oh, let me close DevTools. Yeah, okay, so this is like a card based on like AI doing things for bias. It comes from something a competitive debate student had created. The way that competitive debate students do research is using docx files to kind of like document their stuff. I'm gonna like open up this one as an example. So this is where we got all the seed data from. This is basically like the way a competitive debate student would create evidence for an argument. These are like their pieces of evidence. So we kind of ingested these documents, which debate students across the world have been kind enough to open source over the past few years, and put them into semantic search engine. A lot of the idea for trying to, I guess, like parse those documents that have been open sourced by debate students is that it's a little bit sad that, or at least to me, that debate students around the country put in, so much effort into researching and like coming up with evidence for all kinds of crazy things, and yet have a very hard time communicating that work to the outside world, even when they open source the docx file. So part of the effort here, which I mean, Denz did first with his original project, but part of the effort has been to, I guess, like place that evidence into a like search engine or a semantically searchable store so that it can serve more people and be more viable for the general public. Because I think that, that'd be really cool. It'd be pretty rewarding for like those students, I hope, to see that their evidence is like more widely used. A lot of like what we want to do like long term is if we get more users, we'd like to figure out who made these briefs and then put the cards underneath their accounts so they can get credit for the actual evidence. Right now, we have a user, like this is kind of our business development lead, Jake, who we've put all the cards under, but we'd like to move the cards into people that actually created the briefs, like the docx file that I shared and things like it in the future. With this evidence, like there's a few kind of important like pieces. One is like you're obviously seeing this kind of like what I call inline syntax summarization. So the way that competitive debate students kind of summarize the evidence is instead of doing like journalistic citation, where you kind of use ellipses and like you exclude certain parts of content, competitive debate students have kind of decided that's not a approach which serves their use case. and instead have gone with this approach of underlining, bolding, and changing text size, which you're kind of like seeing here. You have the ability to view the card in a single view, just like what we're doing now at like the /card/UUID route. On top of that, you can create collections for the card. So like this card is currently in a collection for all the other cards in the brief. So if I click this and I take a peek at the collection, I'm really hoping that we don't have demo bugs, but yeah, if you speak of the collection, you can see all the cards that were in that docx brief I demoed. And yeah, these are all of them. You can create new collections where you add the card. So like from this little popover, you're able to create a new collection. So like I'll call this one CDL demo. It'll create, and then you can add the card to that collection. So now if I view the CDL demo collection, you can see this piece of evidence in it, and you can add more evidence to it. For example, like the use case here is if you want to have a argument topic, like say your argument topic is, AI being biased, you can put a large number of cards here. The other cool thing that the service does is it detects collisions. So a lot of times, multiple news outlets will publish a story on the same topic. And when they do that, they're kind of offering different perspectives on the same issue. Typically, people will like cite news articles as evidence when arguing. Maybe it's not a news article, but like a research paper. Again, same thing with research papers, right? People publish the same things in different journals, or even in the same journal with like different editorialization. But a lot of times the meaning is like quite similar, to the point where it's not really worth reading both. And we kind of call that an information collision. So the way we handle collisions is by detecting them via the cosine similarity, like vector search. And then when you click this right arrow, you're seeing collision. So like this card right here is from a different person's brief. Same with this one, right? And they've cut the evidence differently. So the inline syntax summarization is different between like the two cards, slightly, but still. And this one's very different. You can kind of like keep going, and yeah, you'll see like more and more like cuts. This is like a very popular card, but it's a lot of people have like made their own cuts, and they're very subtly different. So we kind of detect that. Even if you were to do something like just not include the last paragraph, that's typically labeled as a information collision by our system. Whenever I do demos, like for other searches, I'll try to show some that are more like different when you query across them. We also added the ability for people to upvote and downvote evidence. The point of this is that, like, again, we want, like, if you are doing a lot of work helping the community by publishing your evidence for like different opinions and topics, etc., you should have some way of explaining like all the work you've done, maybe to a future employer, maybe to a friend, who, like what have you. And adding votes to cards is like our way of doing that. Our search algorithm does not take these votes into account when sorting evidence. Maybe we will in the future. Maybe we'll have a feature flag to disable that. I don't know. But the point really, like with votes as they sit, is to allow people to get rewarded for adding to the community evidence store. If you click on somebody's profiles, like in this case, Jake's, you can see some statistics for like how much they've been contributing. You can see how many cards they've created, their cumulative rating across all their cards, how many votes they've cast on other people's cards, etc. If you don't want your email to show, or you don't want to like support a website using your profile, you're able to hide your email and not have a website. So yeah, try to be like sympathetic to people that want to be anonymous, or that just don't want to get emailed. Okay, so like other than that, I think the other cool things is we have, before I did like the demo of semantic search, we have verifications. So like this card has been verified. When we say that a card has been verified, what that actually means is, excuse me, what that means is that this text that is present in the body of the card actually exists at this URL. And we are leveraging like Puppeteer to verify that content exists in the given URL. We also do the inverse. So like sometimes cards cannot be verified. We have like 2 weeks left to go to verify all these cards. But yeah, sometimes you get something like this where, I don't know, what likely happened here is that the URL is bad. So because the URL is bad, we can't verify that this content is actually at this given place. Sometimes if you're lucky and this one's not in a collection, or like not an obvious collection, unfortunately. But sometimes if you get lucky, you can actually like figure out that, oh, we should actually change that dens. Anyway, so okay, broader point is that you're actually going to be able to figure out by looking at the collisions for this card, if you look at the collection it's in, that it may have another cut of it where somebody put the URL correctly, and that cut could be verified. And that happens like semi-frequently where you can get lucky like that. Now, obviously, for the coolest part. So the coolest part is like not any of those features. The most interesting thing is that when you search for evidence, because it's semantic search, which I have a link here, you might want to, if you're not familiar with semantic search, it's like worth Googling, reading the wiki, some other source as well, maybe. And when you do that, you're like going to be able to maybe get a sense for what the value proposition of it is. So like I recently added this card about the Spartan like military, right? If I don't want to search, like if I don't forget the name of Sparta, or like maybe I don't know the exact text content in my memory, you can search for something that means roughly the same thing. It's like I haven't tested this before, so maybe it's going to go wrong, but we'll try it anyway. So, place around Greece that was known for fighting was actually not that great in terms of their military. It's like a very vague search, right? Like you wouldn't really expect this search to do that well on Google. But when you have semantic search, let's hope that it works the way I think it will. Yeah, so like this is going to give me the Greece-Turkey conflict as the #1 result, which is 84% similar by cosine similarity on the embedding vectors. And lucky enough for me, the demo went the way I wanted it to, and we actually got the card I created earlier about Sparta as a second result. And again, like I don't have much text that matches here. So on a Google search, this wouldn't do that well. If I change it to be a full text search, which is using Postgres, Postgres full text search. It's not using Levenstein distance. I actually forget the exact name of the technique we're using. But if I change to full text, maybe we'll get a good result. Maybe we won't. Let's see. Yeah, you don't get anything helpful at all, right? So like that shows the value of having the cosine similarity on the embedding. It captures the meaning of what you're saying instead of just the text match, which is like really, really powerful and cool. Like crazy enough, like we were kind of surprised, but there's even cards about like obscure topics in here. Like something I searched for this morning kind of randomly was like reptile or fish actually have emotions and should be treated with respect. Like very weird search, right? You wouldn't expect to like, oh, do I have it on full text? No, I have it on semantic. Well, maybe it broke. Yeah, it looks like it broke. Okay, I don't know. Unfortunate. Demo, yeah. Well, okay. Maybe it's bad.
Make it shorter, just try fish have emotions.
Yeah, I mean, like, I don't think that's what went wrong. It seems like something is like maybe the Qdrit. Oh, there we go. Okay. Yeah, so we got something good for this. Weird. Anyway, okay. I think that it went down for a second, but yeah. So we have like a rate limiter, and like sometimes we're hitting the rate limiter. But anyway, here, you can see like crazy enough, we get a card about a book called The Fish Feel Pain in the results from like some guy who did debate research in 2014 about why fisheries are bad. It's like crazy. Like if you go to vault.argueflow.ai right now and do your own searches, as long as our server doesn't crash, which we're doing our official release on Monday. So we have this weekend to like pressure test it. But yeah, if you go to vault.argueflow.ai right now and you make some example searches, I think you'll be really kind of surprised at the quality and the breadth of the evidence. I wanted to do this earlier. So like this is the collision detection stuff. So you're seeing like this card kind of got messed up in the parse, right? It's like the parse didn't go as well as it went for some of the other ones. And even though the parse didn't go that well, it detects it's a collision. So you're not going to get like flooded with two pieces of the same information. It like the system actually like handles and protects against that, which is sorry, this was the original card, which was really cool. And then again, like this one got verified, which is also cool. The verifications have like 2 weeks to go before everything gets processed through it. Yeah, I mean, it's really cool if you guys want to go and like try it and mess with it. Our overall goal for this is to like help serve evidence to other applications. You know, I think that like Mark is going to demo Claim Miner a little bit later, and we're interested to see like if we can onboard more cards from Claim Miner. One thing I wanted to demo that maybe is like working now, but it wasn't before, is we built an auto cut feature that was really bad, but I think it's actually decent now. Sorry. And you know, oh yeah, okay. Anyway, something's wrong. But anyway, it auto cuts the evidence like in a pretty good result, similar to what you see. Like, yeah, see, I think I'm getting rate limit or something. Maybe the server went down. Fuck, I don't know. Okay, yeah, we're back. So you get like a cut version of the card. No, that's not a cut card. Similar to something like this, where it has the syntax highlighting within it. Yeah, so we have a docs page where you can kind of like read more about how the system works. We actually like explain the way that code, like the parsing works in detail. Like if you want to just use it from an API, we give some examples on how to do that. There's also a feature list. So, like I didn't go through everything that we do. If you want a comprehensive review of everything the system is capable of, there's like 18 unique things we've put in the list. I think it spans like all the core features. We also have like full documentation for the API. It's like all of our routes exist here, and you can like figure out how to query them if you want to use it via API or like make a different front end or add it to your application. Yeah, it's like fully featured documents. Everything is also open source. It's like our GitHub has the repositories for everything. Vault server is the core of the service. This is like the Rust Actix web server that handles all the requests, which I was saying was probably going down periodically. And you know, this has like hopefully decent documentation on how to use it. You can like look at all the code here, and you can self-host it if you want. We're happy to share the data. Just reach out to us and we'll get you a copy of the database without user information. So you can self-host or make your own instance of it if you don't want to use ours. There's also the Vault client repository. If any of you guys are building a search engine and you want a pre-built UI, this is probably decent. It's written in Astro, so like it's heavily optimized with SSR. And then the documentation is also open source now. So if you want to go through the docs and like read the markdown without the UI, you can do that. It's mostly in this, oh, not the MDX folder. It's in the pages folder, I think. Yeah. So it's mostly in this pages folder. We have like all the MDX files if, you know, UIs aren't your jam, or you just want to clone it locally. Yeah, I think like that completes like most of the demo. Happy to answer any questions.
I had some questions. Thanks for demoing.
Yeah.
I didn't fully understand a card. So like on a card, I see a URL at the top. And so part of my brain is thinking, okay, a card is a URL. It's like a single, you know, locator to find the thing. And then, you know, stuff below will relate to that URL. But then there's also the docx. And so that part of my brain is thinking, no, a card is the document. So can you clarify, like, how do those two relate?
Yeah, a card is a URL and then content from that URL. The reason why a document is there, along with the OC file path, is really just because we're trying to give credit to the people that made the evidence cuts to the best of our ability. So we want to include the original document, and we want to include the file path from Open Case List, which is where we got the information from, so as to give people credit for their work. But okay, so it's not core to a card.
So debaters have verbatim copied URLs and then into docx's usually, and then have
highlighted,
formatted them in a way that's accessible for them to use and debate.
Correct. And we parsed all those.
Okay,
we're just trying to give them credit to like best.
Yeah, no, that makes sense. I just didn't understand. And then second question is, so I'm thinking about how people might use this in an enterprise setting. And in my mind, I'm imagining there's a bunch of documents spread across an org, and people are like little worker bees or ants, sort of like finding things and having questions or wanting to use bits of it, but they don't want to use the entire document. But I guess that's okay. So you would, okay, so the question of how you locate it is one question, but let's assume it's URL accessible. And so do the people need to refer to the entire URL, or can people like pick snippets or excerpts from what they're referring to? Because I'm imagining, like, if I find a document, it's like a 30-page, who knows what, a report someone wrote, and I'm really only interested in one part of it, like a paragraph or a sentence, which seems interesting or contradictory to something else I saw or something I think I know, I'm probably just going to want to highlight that part and do something with it. Is that something that you're contemplating?
Yeah, so if you want that, you would manually create a single card. If you upload the file, so like let's say you have a 30-page file and you upload the whole file. I mean, I think Mark's work is more advanced than what we have for parsing that. But we would use like something like Mark's work or like a different parser that we build to actually pull every single paragraph, heading, base section, whatever, out of the doc, not whatever, I don't like that word, but arbitrary like heading sections or paragraphs out of the document, and the company or the person uploading can select the parser that they want to use. But that'd be the whole document. Or if they really only want to add a single paragraph to the embedding store, they can manually create a single embedding. In an enterprise setting, like I don't know how to work. I think people are going to want to export their notions to Markdown if they're using Notion, or like, I don't know, all the Notion competitors. We have like a list of them, and they're probably going to want to export that and then parse it somehow into a semantic like store of stuff. I'm still not 100% sure people are going to want to do that, but if they were, that's how I think they would do it.
Okay, and it's okay to have multiple cards with the same URL. Is that right?
Yep, and if you copy and paste the same paragraph, and like we just detect it's a collision, and we display both. It's like we don't reject you being able to create it. We just,
Gotcha.
when you search, you will never like in vertical like list, you won't see the same card twice. That appears like horizontally in a carousel. And I mentioned earlier, but we call that an information collision.
Cool, thanks.
I get three things, but first, kudos on the documentation. Like, it looks amazing, so really easy to kind of go through. That's awesome.
Thanks.
First was generally a question of, you said debate students use those docx's and they format them. Is that all that formatting, like the underlying coloring, sizing, bolding, is all that done manually by these students? That seems,
Yeah.
that seems like a very, I feel like that can be improved just in general.
Yeah, we trained a model to do it. It's like we have a model now that does it. Unfortunately, I couldn't demo it. I don't know why. I'm looking at my co-founder Denzel is right here. Say hi, Denzel. But yeah, I was looking at Denzel right now because like, I don't know why it's not working. AutoCut's broken for some reason. Anyway, so yeah, it was working this morning. But yeah, we built a model that does the auto cutting for them, so they don't have to do it anymore. But like I said earlier, they've put in so much effort. Like competitive debate students across the country have put in so much effort, and it really made me sad that it was buried in docx files nobody could use.
Yeah, totally. No, I guess I meant just in general of them creating the docx files and doing all that markup manually. Seems very tedious, but anyway. And then my question was, next question was for in terms of upvoting. So I'm curious on what you are upvoting. So you're upvoting a card, but a card is evidence, and evidence for what is, so it's kind of a two-part question. Like when a user is upvoting, what are they actually upvoting?
Okay, other co-founder Jake. Okay, sorry.
No worries.
So when a
Yep.
user is upvoting, they're upvoting the cut. So like a really good cut, meaning a really good inline syntax highlight, could be worth upvoting. And they could be upvoting the cut. If they're not upvoting the cut, then you're upvoting like the excerpt. So you're saying this excerpts are useful. And then two, you could be upvoting like the source. Like if it's a New York Times card, you might upvote. But if it's a Salon card, you might not.
Interesting. Okay. And so when is there a distinguishing factor between cards and evidence, or are they synonymous?
Synonymous in our system. So like a card consists of content from a URL that you have maybe syntax highlighted.
Interesting. Because I always think like evidence for something. It's hard for me to conceptualize just a general, this is evidence, but that could just be me. And likely it's just me. But last, go ahead.
I was just saying, like, I don't think it's just you. A lot of what we built is geared towards the competitive debate community, and I think that they have their own lingo and terminology that is unique.
Totally. And the last thing was I tried to create an evidence, but Chrome gave me this security error. It was like a dangerous, deceptive red screen. That's what it.
Yeah, I know.
Okay.
We saw this more with somebody else. I don't know why that's happening. Our SSL cert's like valid, so like something is going on where Chrome or like Google doesn't like us. We are a fairly anti-Google org, so it's possible that I don't know, we did something to like make them mad, which isn't unlikely. We try to not use anything Google at all ever, so probably fucked up somewhere.
Fair enough. Okay, that was it for me. Thanks.
Okay, strike two for me. Unless any other questions.
Well, if you're looking to fill time, the only thing I was just gonna say, Nick, and I mean, I mean, it sounds like you guys will just have this sitting around. You can always refer to it, and you'll learn more, I think, with your, when you kind of focus on enterprise later. But I just want to say that having been in some organizations, there's a lot of docx's sitting around. People love creating docx's, and the fact that you can capture evidence in place with formatting with a docx may be very powerful for enterprise later. Like, I don't know. I mean, maybe you'll find out, but I'm guessing the orgs that have Notion databases sitting around that they can export somewhere, those are going to be very cutting edge and small. Whereas there's tons, I think, of orgs that are based on Windows, Microsoft, Office, and docx repositories. And what's that thing called? SharePoint? Yeah, SharePoint, I think, is their like document collection system. But yeah, you'll learn more later, I guess.
Yeah, if you know anyone, point them towards our direction. We'd love to talk, because like
Okay.
the hard part for us, just we're not doing enterprise because the sales cycles are too long. It's like, you know, we're kind of like gonna die if we can't figure out how to like continue existing in the next 1 to 3 months. And an enterprise sales cycle is probably 6 months, so we're kind of punting on it. But if you know people that could shorten the sales cycle for us, that'd be awesome.
Yeah, I'd have to think about what the use case would be, and then think who. I mean, my connections, that I have, which are not many, would be like lawyers. Trying to think what they would want to do with it. I mean, definitely evidence and law go together. I'm just trying to think of the flow that would work. But sorry, Mark Antoine, are you ready? I don't want to cut off your demo. I wasn't sure if you were looking for time or ready.
I'm ready.
Okay.
Okay. So the idea is you have a bunch of, okay, so this was built for Society Library. The idea is to help them in their workflow of creating claim graphs from various things they find around the net. And the claim graphs are built in debate map, and that's a separate thing, and I'm not going into that. But what I wanted to help was the gathering evidence. So here are documents which were added to this claim miner instance. We can upload new documents with a URL. We can upload a file. Right now it accepts text, PDF, HTML. I should add docx, why not? It's not terribly hard. And when it gets PDF or HTML, it tries to, and that's really important, it tries to segment it in paragraphs. Now, this is not a very successful one because there were not many paragraphs, or the HTML paragraphs were not very useful. I skipped, by the way, the here's the original link. We can just go to it, and here's the kind of raw, oops. Okay, another demo effect. The raw files are not available. I don't have admin on this instance, and there's many things that probably work for admin. Or I'm not showing admin for reasons. So, but normally you have the original file that was downloaded and cached. And that can give you the original text. But in theory, what you get for anything is here are the long enough paragraph from the text. If you look at the numbers of paragraphs, by the way, it shows you that a lot was skipped because presumably it was too short. And it should be possible in many cases to, but this is a PDF, so there's, this is a better example. Those are reasonable paragraphs with multiple sentences. Something I want to do eventually is be able to cut the paragraphs by hand and say those were actually not cut well by whatever algorithm, and resegment the paragraphs. Each paragraph gets its embedding, so that if I do, of course, I have the basic text search, So I could do this is the Diablo Canyon collection. So I can look for nuclear power and look in the paragraphs. And then I get, this is obviously highly ranked because it's long and it's got the word nuclear power many times. Not terribly interesting. More interesting if I do a semantic search. I will get, I'm also getting long things. Okay, let me get actually question. No, finally it did it. Nuclear power. Here I get a more reasonable thing. Let me get connection. So it's the same thing that Nick showed. I'm using PG vector. So this is a cosine search. Nuclear power, nuclear waste takes a long time to decay. So here I get all these paragraphs that are close to that sentence. And I can search in paragraph or I can search in claims. Let me just get claims. These are claims that were identified as, basically they are sentences that were identified as relevant. And then I can look around that claim and get, here are paragraphs around that claim. And here is where it really, and those are from different documents. So what's interesting is I can take those sentences and maybe go further in the collection, and I can take a few more. Now I have 12 fragments. And say, this was not a question, so I should really start with the question. Let me look in the claims if I see something that's in question form. Let's take this one. It's not a question, but let's assume, let's treat it like a question. So let me again take those claims and then do LLM analysis. So basically I'm saying, well, I'm telling an LLM, this is a question, those are extracts from things, get the basic prompts. So basically there's, these are the original fragments from the documents. And then I'm telling the prompt, okay, make those into claims and save those as claims that would be related to this thing as if it were a question. Normally I should filter on saying, this should only apply this prompt to actual questions. That's future refinement. And then I can save this and I can export it to Claim Miner. I won't save it. This is a live database, but I'm trying to show the basic idea that once it's saved in Claim Miner, and there's another thing that allows me to change. If I look at, that's the only prompt I have right now. This is kind of the prompt itself. This is a high-level abstract question. These are quotes. So I can add a prompt with a different prompt, and I'll get basically, here are the themes, here are the fragments, and generate the claims. And what's important is I'll say, oh, by the way, this is generate claims of this type with this relationship. And so basically these are different. This is not really what Society Library uses. This is something I was playing with, but we're working on having an ontology that will allow us to kind of pre-populate the argument mesh using this. So the claims which are there, which are right now mostly isolated, but they're actually, they can be connected to different, I could have prompts that act directly on a claim. By the way, we don't have one live in there, but we could, for example, get the negative form or things like that. But most of the claims will be designed to work on, most of the prompts will be designed to work on fragments in relation to a claim. And then when I look at the document next, there's a lot that is not showing because I don't have, we have something that has, this one has 10 paragraphs. If there were claims derived from those we would see them. We would see, oh, by the way, this was related, this was analyzed, and we extracted this claim from this paragraph. So sorry, there's a lot in the demo that's missing. Let me see if there's claims that were used in paragraphs.
Sorry, Mark Anton. I kind of missed the basic prompt you were doing. So you're taking an abstract question, which is sort of the context the person's in, like what they're interested in answering. And then
Yep.
you're giving them excerpts or fragments, or sorry, them, I mean the LLM. And then you're asking it to create a claim based on every fragment.
Yes,
that
exactly. Yeah.
Okay.
So, okay, let me actually create a question. Is nuclear power safe to use? Okay, so that's a question type claim.
Mhm.
Now that I've used it, I'll go, here's a search. Oh yeah, embedding not there yet. Okay, embedding is there, good. Now I have the embeddings, and these are extracts from the documents that seem to be relevant to that search. This is using a pretty poor embedding. I have a choice of using the universal sentence encoder or the ADA2, which I'm not using by default because of costs. So this is a primitive embedding, but I can add models in theory. That does require a recompile, but it's pretty easy to add new models. So I can take these and maybe a bit more because those are not exactly convincing. Okay, let's take these, check all. So there's 20 fragments. And I'm saying LLM, I'm saying give me positions based on those claims. And then it's giving all those fragments. And then they're saying, okay, here are actual prompts that are found in those fragments. Like here are the prompt found claims in those fragments. And each of those, it should be telling me, oh yeah, that one comes from this. And I don't know why it's not saying that. That's a bug, actually. It's lost capability. But at some point it would tell me, oh yeah, this one is coming from this fragment. This one is coming from this fragment. This one is coming from this fragment. So that's something that's possible. And then when that is, when I find that one of them is a relevant claim, I could save it, and then it becomes part of the kind of claim map I'm trying to build. Nick, you're muted. I don't know if you wanted to say something. And then basically when I have claims, I can look at clustering. So this is basically a classic semantic cluster utility. And then I can say, oh, these should be linked together because they belong to the same cluster and I should disambiguate. Or I can do, this is a bit weird to show, but this is the actual data that's from Claim Miner. And it's used, this is purely for demo purposes, but I can get semantic scatter plots of the claims I have in the system right now. So I can show the cloud of, these are all the claims that in the system, well, in this part of the system, and how they are clustered in using different clustering algorithms. And that is of actually limited value, but what's really important is the ability to go from, basically you add documents, you add, they get parsed into paragraphs, the paragraphs get embeddings, and that is used for semantic search. And you start from your claims and you say, okay, what is the semantic neighborhood of those claims? So I can use them directly as evidence. I can say, in theory, if I start with the claim, I should be able, one second, I'm not sure if that's even doable. If I start with the claim and search and find a paragraph, Yeah, that's not possible. That it should be easy to say, well, this paragraph from this document is evidence for that claim, but that's missing. But what is possible is to send it to a prompt machine that will say, oh, by the way, here's the claim connected to that evidence and keeps that connection. That is sent to debate map, by the way, the claim and the evidence connected, like the original paragraph as evidence for that claim. And that is used to build claim graphs in debate map. So this is half a solution. It's a bit weird to show it without showing debate map, and I should get into it. But do you have questions about what you've seen so far in the usage? Oh, by the way, we also have collections. So you have kind of restricted view on the claims that are there. And it's absolutely abnormal that the documents are not, there's not more claims there. Oh, one thing that's cute, I said, it is dangerous if I get a semantic search, I get a lot of stuff. I also have a MMR search where it will look for different things. That's particularly low quality. It was better than that. Not sure why. Why is that even? Powers.
What is MMR?
MMR means it looks for the closest paragraph that corresponds, and then it looks for the closest paragraph, the next closest paragraph that corresponds, but that is far enough from the first hit. And then the next one that's far enough from the first two hits, and so on. So it kind of forces divergence.
What does it stand for?
I forgot. Multiple, it would be in the source. No, I totally forgot. This is.
If I do MMR clustering, that's kind of the idea.
Yeah.
Okay.
It was, this is done in database, by the way.
Min roughness. Does that sound right?
What?
Min roughness.
No, it's not right.
Okay.
MMR. Oh, maybe it's right. Yeah, maybe, no, I'm wrong about it. You're right, it is min roughness. Okay, interesting. What else is useful? That I'm getting weird results. It's beyond the Diablo effect. Sorry, beyond the no claims yet in Diablo Canyon. That's ridiculous. All of these claims should belong to Diablo. It's as if it lost its link to the claims. I'll look into that. Okay, this is the artificial intelligence work. There are claims. There's tons of documents. I prefer working with the Diablo Canyon example. It's true that if I work with the AGI example, AGI, that's a classic. The advantage is I get the better semantics. And I get, okay, let me do the MMR here actually. Should be more explicit. Okay, so here I get, yeah, I get a kind of guarantee that the claims are far from one another, and there's a kind of temperature, and here it will look for something. These are closer together, I think, and these will be more dispersed. So yeah, work in progress, but the main flow, the other flow that's important, oh, I guess I should show that. Claim search. What is the path flow? Totally forgot where it was because it's not totally obvious. Search. No, I am sorry. There is a flow where basically you propose a. Yeah. Now I'm remembering. Claims. Propose. Add claim. I think it's propose. Yes. So there's a flow that's a bit helpful for newcomers, and I should make it more obvious. Where I say AI is capable of deception, for example. It will look at existing claims in the system. So you can relate it to the existing claims, or you can say it's totally new, add without relations, or you can say, oh, actually, it's pretty close to this one that already exists, so I don't need to add it. So it's a way to curate your collection of claims and make sure that you're not duplicating endlessly. So yeah, if I say relate to, yeah, is able to deception. Well, it's opposed by, that's an argument. Actually, it should be backwards. And this claim is already, AI will import democracy is already in a free-form relationship with this other claim. And right now we want to make the claims less free-form and more. Here's an example. So these are, oh yeah, these are big claims that come from a collection. So they're not as interesting. But you have these relationships between existing claims. I think this is where we're at. Do you have more questions about either what it is or the goal? It's work in progress. It is now open sourced. Unfortunately, the project of tasks is, I'm showing you, this needs to be made public and I don't have the rights to do so. But there's a lot that is planned for this, where I'm going. But this is the existing state. Oh, and there's an admin where you basically allow different people to do different things. And you can also do that per collection. You can give per collection rights to people. This is my personal instance. And you can add collections. And yeah, this is the full, you'll see a bit more here. What else is useful? Text search, documents. Here we have, no, okay, that I really need to repair. So the difference between this and what Nick is doing, Nick is supposing that the documents are already extracts from. Oh, one more thing I knew I had one more thing to show. Sorry. I won't launch it, but there is, the reason we choose the universal sentence encoder is that there are collections such as of news site that do universal sentence encoder in Google Big Data. So I can do a GDELT query on, I don't do it often because again, there's big cost involved, but it's possible to look at all news, do a semantic search on Google Big Data for a given sentence, for a given claim. So create a claim and launch a big data query on this GDELT data set. And you'll get news items related to that. And again, take those news items and add them as document to claim miner. The idea is to leverage the existing embedding data sets to find evidence. Like, I think it would make a lot of sense to communicate to the vault and find these things. But the thing is to be able to really add free-form documents of websites that are relevant to something that may not follow the argument format, and use the decomposition to paragraphs and eventually into subunits. I do want to subdivide into sentence and quotes. There's a lot of background infrastructure that's there already to say, okay, what is the most relevant quote to support this claim, and use that to build the claim network. So that's the overall goal, working with free-form sources. This is all Postgres, PG vector. The NMR is done in Postgres with the Python PLSQL, PL Python function for the heck of it. There's a lot that I did for earlier systems that I won't show, but so this is a truncated version, but still there's a lot about claim structure. Like right now, what I'm trying to do is to have more and more of the claim structure and claim miner, so that it's you can work with the claim network in claim miner itself. But the main goal is to feed debate map into the analysis in debate map. Michael, you have a question?
Yeah, but generally speaking, this was amazing to see. There's so many things you're doing that I want to learn more about and take a look at. So that was incredible. But the first question I have was, so in terms of extracting the claims after you've taken the paragraphs out, you're doing that via an LLM and prompt. Okay. Are you looking at changing that at all, or does that seem to work good enough? Or
it's working. I'm certainly interested in many more options. The point is to have a test bed where we can try many approaches. I'm not saying claim miner is not used much right now. It's not yet good enough, to be absolutely honest. And also, I think there's a learning curve. The UX is what it is. But what I think is really important is it's trying to have, oh, there's an API now. But what's really important is to have this, and I'll reuse Nick's term, a vault for document, where we can do generic, let's put documents in and do stuff with them. And be able to, in parallel with, here's our claim vault. So the idea is to have both a document vault and a claim vault and see how we can make them interact. I don't pretend I have the end all and be all for either of those functionalities, but making them interact is really important for me. And for me, the claims are these really small things, like what I'm seeing Nick is doing is have sizable evidence for the claims, because he's not taking subparts, he's relying on the highlighting to find the subclaims. I'm perfectly comfortable having subquotes. It's something that's written in, actually. It's possible to see, oh, here's a subpart of that thing that is there and it will be displayed. I'm not showing examples, but there's for reasons, but it's that machinery is there, saying here's a quote taken from this paragraph that is more useful evidence for this claim. And being able to keep those links between text from the document, so we have the source, and text from the claim debate map machinery. Right now, I'm still spending a lot of time thinking about two-way sync between debate map and claim miner. That's the society library need. To be absolutely honest, I want to replace both with a slightly different architecture, but that's long-term planning. And this is the event sourcing experiments I've been telling you about. Maybe that's something I should show next week, or maybe in 2 weeks. I'm not sure I'll make next week, but that's also evolving. But the basic idea of we have a bunch of claims and somebody's putting them into a certain shape, and we have a lot of documents and people are relating those fragments of those documents to claims. I think that's generally important. And what I'm trying to do is a base database to allow that. I have played with claim abstraction using NLP technique. That's another project I could show, very, very toy at this point, but it exists. I have not played that much with LLM besides just generating prompts. I'm more interested in getting many processes, including human, including NLP, include classic NLP, including LLM, sure, no problem. And creating this database of, we think there's this claim in this paragraph, and then having people vet that. Is that real? That's really what I'm trying to do here, to have a vault for how good is that evidence for that claim in terms of different documents and citations.
That would be incredible. Yeah,
that's the goal in claim miner. It's a small part of the CDL. The really important part, of course, is the claim disambiguation. The saying here's the neighborhood of this claim is really the version 0 of that. This is where all my future work lies. But the short term right now is getting the event sourcing working so I can rebuild on that basis. Nick, you're still muted.
Didn't mean to talk, sorry.
Sorry. I'm curious your reaction.
Yeah, I don't know. I think it's cool. I think a lot of it is interesting. I have a lot of concern on like not handling information collisions. I think those are a lot more common than you'd think, especially when parsing arbitrary information. So yeah,
what do you mean not handling information collisions?
So like you don't want a situation where you have like a search and then you get 10 results that are 99% consistent similarity. You want like 99%.
Which is why I put the MMR in there.
Okay. I don't understand how that works then.
What the MMR does, it's basically, here's a bunch of results. Okay, here's the first one, which is supposed to be the best. Then find the next best one that is far enough from the first one. Then find the next best one that's far enough from the first two. Then find the next best one that's far enough from the first three.
Yeah, that might be a more advanced way of handling collisions, but it's a lot more expensive. So like, I guess a few things. One, we're using QGRID, not PG vector, which I think is important because if we were using PG vector, queries would be about 15, 20 seconds. Right now,
that's not what I showed.
Yeah, but we have 940,000 embeddings. So it doesn't start to like really make a difference till you're in like the hundreds of thousands.
How many do you say?
940,000.
Okay, fair enough. I don't have as many at this point.
Yeah, when you start to get hundreds of thousands, like I definitely think that PG vector.
Yeah, I'm at a few thousand at this point. But you may be right. I'm not defending PG vector versus Quadrant here. And no, by the way,
yeah,
Quadrant has an MMR search.
Yeah,
I'm defending the approach that I don't think. Okay, if you say avoid collisions in search, yeah, sure, absolutely. But saying I don't handle it, like if you're saying PG vector won't scale. Okay, cool. Let's make tests. PG vector is also evolving, but I don't care strongly. And I'm rebuilding the system, and I will look at weight run. What I do think is important is to have a more, like, right now you're cutting documents, assuming, and that's fine, it's your use case, assuming that they've been highlighted by they're already extracted segments. Each card is evidence that is self-sustained. I'm more interested in, okay, if I take the paragraph and I break it up into something smaller, I have document level embedding, paragraph level embedding, and I will have sentence level embeddings. And I have a few actually, and quote level embedding. And let's find of course, I won't do all the quote level embedding. Those will be on demand. Same with the paragraphs. But I think being able to search at any level of granularity. One thing I want to do, and if you want to run with that idea, you're absolutely welcome to, is when I find a good paragraph, let's break it up in sentences and rerun the embedding engine on that. So that we get, okay, here's the important thing. And let's even do it at the clause level, which we can do with an LP. That's, for me, really important to be able to say, what is the unit of evidence that is not necessarily coming from human extraction, but can we find smaller extraction? This is where I think automation is really useful.
Yeah, so I didn't get to finish what I was saying, but it's like a few things. Like with that approach, there's it's like, okay, one in QGrant right now on like the super large blocks, we're at like 900,000 embeddings, and QGrant, we're also using ADA from OpenAI, which means that our vectors are a lot larger too. But the issue that happens is if we were to make more embeddings, so like if we were to break it up like further than what we already have, we'd end up with more than 900,000. And the query time is already getting to a point where it's like 1.7 seconds to 2.8 seconds. So we're trying to minimize how many embeddings we have to the greatest extent possible to like preserve performance. And I think that the way we handle collisions is a little bit improved on that, because we managed to do collisions in the OLTP DB instead of the vector DB, which I think is a lot better for perf. That's what I was trying to like explain. I didn't get to finish. And then the other thing is like, this is more macro level. So like in a world where vector DBs actually do get, orders of magnitude better, maybe that happens. I don't know when, but maybe it happens. I think the value of embeddings is on larger blocks of text, not shorter, because having an embedding for a sentence is not that helpful. It's like easy for a human to read a sentence and get the meaning. Having an embedding for 3-4 paragraphs is a lot more helpful, because you want like a gist of what the 4 paragraphs contain. Once those 4 paragraphs are rendered, it's very easy to feed it to an LLM and get the LLM to pull out the important piece from those 4 paragraphs. And that's cheap. So I see it as like, you actually want embeddings on very large blocks, and then you can take the large blocks and feed them to an LLM to get them down.
I agree totally.
I don't think that it makes sense to do I think that's the value of embeddings. Like that's the entire reason why they're so great. I think the value of embeddings kind of gets lost when you go to smaller and smaller pieces, which is,
let's be clear first. I totally agree with you. Doing embeddings on very small fragments is only useful on demand. What I said is, if you decide this paragraph is important, then let's break it up to find what's more related to your thing. And you're right, this could be done by LLM. But then I would still, once the quote has been deemed important and delimited, I would still have the embedding for that, because next time I look around with a new claim, I think it's good to see if very tight quotes fit that new claim. So I would add it. I would not add all small things there, I'm with you. But finding the neighborhood of a claim, which is the prime function of claim miner, so that, what quotes are appropriate to that. It's perfectly reasonable for me to put the designated quotes, like sub, very short things in the mix. There won't be that many of those. Putting all the sentences, I agree, that's suicide in terms of performance. The collision detection, now that's interesting. collision detection.
Wait, I'm sorry, really quick. I just want to say this before you continue too much. With that sentence, I would think that you should relate that as something in your transactional DB, not the vector DB. So it's great to have that quote, but when you do the cosine similarity search, you'll find the embedding, and then you can show the narrower quote off that embedding without having to create one for it. Because there's not even a guarantee that. Yeah, because I again think that it's fine just relate it that way instead of relating it instead of making a whole new embedding. I think they stack on top of each other in the transactional DB, not the vector DB.
Okay, you did not understand my argument. I think the idea is in this query it makes perfect sense what you're saying, but then I would save the new embedding for a non-related query because I think it might be useful then. Because I don't know. In my next unrelated query, I might not find that paragraph again, but I might find that this quote is a more precise answer. Again, we're not dealing with the same kind of data. And I think that shows you are taking these cards that have already been isolated from large scale documents. I'm dealing with documents, some of which are from net search. So there's a lot of noise around them. And being able to say, this is the part that's relevant in this random stuff is really important. It's really valuable. So being able to say in there, if it's all over the place, I want to know that this paragraph that's all over the place and has a lot of noise, here is the fragment that happens to be relevant to a certain search. And being able to use it for a totally unrelated later search, I think adds value. But your point is well taken that in the near time, I agree. Probably LLM is a better answer. That makes a lot of sense, and thank you for pointing that out. I will experiment with that. Now, the whole you doing collision detection in advance. How
Wait,
many of you...
I don't mind responding. Michael, do you have anything you want to say? Because I kind of wanted to. I was going to.
It's a tangentially related topic, so I don't want to change it until you guys are.
Hash this out.
Yeah.
I was just going to say, the other thing is the embedding model in general. If you so we played a lot with ADA in Jupyter Notebook. So see how good it was, and our conclusion was that the embedding model itself, who knows how? It's very black box, but it does quite a good job of pulling out of what do you call it? The embedding model already does an amazing job of pulling out the interesting information. It's most of the noise is already getting filtered when the embedding is being made. So what we found was that when we took super noisy data, it's an example case we have our parser fails sometimes, and we end up with an 11 block card. And then you would think that, okay, 11 block card, this is going to be way too noisy. If you are making a search that only targets one paragraph, you won't find it. It's what we thought. But when we tested it in notebooks, that wasn't true. Even when you were only searching for one paragraph out of a 13 paragraph card, the cosine similarity was close to the same as if we made was within 0.01, 0.02 difference compared to when we had only one paragraph out of the 13 and then search for something in that one paragraph. So we just didn't see. So I think that there's
is
some
that true?
work
Is that
there.
true mostly of paragraphs at the beginning or at any position?
We tried 7 through 10 mostly. So we were looking for middle. We didn't try. I don't think we actually tested. We didn't thoroughly test this because we were
but 7 to 10 is already impressive. Okay, that's interesting. That's data for me.
But basically, I just think that you should play with embedding models. It's all I'm trying to say.
You also need embeddings for the paragraphs because people don't want to read through 15 paragraphs to find the part. I mean, they may, but some people don't. Some people who are looking for very pointed information, the recall, being able to bring it there is part of the issue. I mean, it's a type of precision too, but also the type of accuracy, bring them right to where it's actually talked about, other than just saying, yeah, it's in here somewhere. I mean, that is interesting. I agree. Sorry, let me preface what I'm saying by that. Is interesting that accuracy was found regardless whether it was paragraph or not. But is there a next UX level of getting people right to the information they're looking for?
Yeah, I 100% agree. But it's it's doable. For example, you can ask the LLM to actually change the so you can ask the LLM to transform the returned regular like plain text into HTML, where a background color on the closely matching sections are yellow. And the LLM can do that for a fraction of the cost of making an embedding. It's literally 2 orders of magnitude, or in like the pricing for doing this like on your own GPU or even on somebody else's hardware like OpenAI, it's usually 2 orders of magnitude cheaper to let the LLM handle it. Because like the super dumb LLM models, like the really like old ones, can do that just fine. Whereas the fancier like new embedding models are at least 1 order of magnitude, if not 2, more expensive to handle that on. And it just makes a lot more sense to let the LLM do it. You have like some latency there, but the latency is at milliseconds. Whereas making your embed, it's like, okay, pricing, it's better to do with the LLM. Then also latency is not, like the latency hit you take asking the LLM is lower than the performance hit you take increasing your vectors in the vector DB. So for both performance and pricing reasons, I think it makes more sense that the LLM pull out the specifically relevant information for you than to make more narrow embeddings.
Very interesting. No, thanks for that.
My question's actually kind of related to the on the other side of that. And I'm just wondering if you guys are doing this or not, or how it works. And it was adding a step to the query embedding, like the user query, and taking that as an embedding and searching for the embedding of the documents. Do you transform the user query? But I'm wondering if based on both of your guys' use cases, you don't, because it's fairly, like Marc-Antoine used to have the specific question and Nick was generally the same thing. I think where I read this was useful was like a chat bot saying, taking your entire chat prompt and parsing or transforming that to here's the specific thing the user is searching for that I need to query the database for. Does that make sense?
Yeah, 100% makes sense. And the short answer is that no, we don't do it, because like with the LLM, it makes a lot of sense because the LLM's context window is very easily polluted. Because the LLM like has a encoding layer to it where it takes your raw text and encodes it into a vector where it like then begins its propagation. We don't have that. We just do a cosine similarity search, which means that if you change the exact wording of your query like around 10 times, as long as the core meaning is the same, you get the same results, which is like fun to play with. Like if you go to Vault and you make queries for something, and then you go to ChatGPT, tell it to reword your query, the text can be wildly different and you'll get the same result. It's even true that if you translate your query to Russian, you'll get the same result. If you translate your result to Spanish, you get the same result. Like it really does not matter how good, like what is in the query string. As long as the meaning is roughly the same, your cosine similarity check will go through. And that's obviously dependent on using like the best of the best embedding models, which is really expensive. And we've kind of just eaten that cost. If you're on a tighter, like if you don't have the privilege of using the best embedding models, like it's obviously not the same kind of quality. But yeah, it's like really cool. Like the short answer is that like no, because the context of the search doesn't make sense. But like doesn't matter. But like for an LLM matters a lot, where it makes sense to like transform the query to English before you put it in the context window. Because if you put Spanish in the context window, the LLMs are more sensitive and they'll start outputting Spanish.
Interesting. I also just embed the user's query. It's without pre-processing. Where I do pre-processing is more in the creating the prompts, saying, here's the claim, here's the fragments. Let's try to get more claims out of that. But
I wonder if it's maybe just my understanding is not deep on this, but could it be the case that when you ask a specific question, a specific domain or context, the answer is different, or in terms of the meaning of the answer and the meaning of the question, or no, am I completely just misguided in understanding?
I mean, if you transform the meaning of the search, like I think that definitely changes the results. Like if you're searching for like aquatic life, like if you're looking at like the hormonal systems of aquatic life, and then you change that to the hormonal systems of land life, you'll get different results. But like if you, instead of looking up the hormonal systems of aquatic life, change it to the endocrine systems of animals that live in the sea, it'll be like the same result.
That's a very good point. I mean, okay, let me restate your question in a strange way. Right now, what I do is, here's a question. Here's the semantic neighborhood. Look for answers in the semantic neighborhood and in the paragraph semantic neighborhood, and then try to extract answers from those. So I'm kind of getting the only semantic neighborhood to get the answering paragraphs and the answers from the answering paragraphs. One thing I have not tried, which would be interesting, is to just take the question, go straight to the LLM, what answers do you have, and get a lot of different answers from the LLM with a good temperature. And then look for semantic neighborhood of those answers in the documents and say, oh, by the way, here are possible way. Is there anything in my database that matches those answers? I have not tried that approach. It could be extremely interesting.
Yeah,
I really want to
the
say
answer.
something here. I'm sorry.
What?
Please do.
Yeah, so basically, like, I'm working on a blog post where I explain this, but semantic search is a post hoc search, meaning semantic search is not the search you want when you have a question. Semantic search is the search you want when you already have an opinion. So like, when you search semantically, you're searching, you're not like, it's very bad for like open-ended research, semantic search.
Yep.
Because
Makes sense.
you can't ask it questions. Like if you want to do open-ended research with semantic search, you have to put yourself in the mindset of different user profiles and then write queries from different user, or write statements from different user profiles, because you're going to find evidence that's similar to your statement. It's like, this also happens with Google or like traditional search engines to an extent, but it's much greater. Like it's enhanced by like several fold. I don't know if it's order of magnitude, but it's like, it's so post hoc when you do semantic search. You're going to get like exactly what you put in. So if your question's opinionated, yes, same.
Then isn't the solution that Marc-Antoine just proposed the answer? So if you ask a question, ask that question to an LLM, get a bunch of different answers and search for those answers. That's your actual query search. So the user searches the question, then the LLM, and then the search to the database is all of, are any of these answers in there? Wouldn't that be good?
That could be good, but like it would be bad UX, because you'd have really high, like every search takes like 2 seconds on our data set, which is like, QGrant is optimized, like we can get it, we like vertically scaled, like we do some like page size optimizations, like all kinds of crazy stuff. And it still takes like 2 seconds to get a result for a single search. So if you were to like try 6 searches or like even like 3 or 4, the response time gets so slow that I don't think it's worth. Whereas it makes more sense to let users do that themselves. So like you kind of just have to like educate the user with the fact this is a very post hoc search, and then let them like do it.
But that's easily solved, right? You could give the answers, the LLM answers at once to the user as a result, and then have kind of background processes searching for each answer's neighborhood, and then populate them, let them fill in, or even let the user direct or ask for what's in the document. I think what's really important is we know LLMs hallucinate, and getting matching the LLM's answers to known documents is extremely important in terms of evidence finding.
Yeah, I agree. I think it's interesting. Like one of the things that we actually created before, I don't know if I ever demoed it, but we have a chatbot like UI and like experience we created where we Vault server has a lot of data for it, but we re-implemented like all of ChatGPT upwards of the model, including like a front end where you can like have a chat. That's at I haven't tested it in a while, so forgive if it's broken, but it's at chat.arguflow.ai. Or oh, sorry, coach. No, it's not chat. It's coach.arguflow.ai. And it's basically just like a debate coach. And we're considering adding the ability for the debate coach to cite evidence like from Vault, but I don't think there's demand. Like I think, like, at least in my kind of opinion, I think that like people just want to like search for their opinion post hoc most of the time. And I think like if we started adding stuff to the UI where it was like, oh, you know, try this alternative search to get the other perspective, people, it would be like too busy. And like, I don't really want to do it for the UX, because I think if people want to do that, they can do it on their own, or they can ask like ChatGPT for it. I don't think our UI has to serve it.
Fair enough. Different use cases again. The really thinking about the what is important to me is we're both trying to create this vault of information. Now yours is specialized for this debate stuff. I'm trying to make a generic one. As I said, I'm not attached. I was going to rewrite my whole thing for other reasons. I'm not attached to my technology, but I am attached to my use case, of course, which is, you know, generic, throw any document and then play with different scales of embeddings because it matters, or play with different ways to carve out the document, because being able to extract evidence from the documents and relate it to claims put more abstractly that's my use case. I don't know if that's like you're dealing with your cards are both evidence and claims up to a point, or they're related to claims in a
They're arbitrary, because like you can just go to a random URL and publish your claim and then put it in Vault, like put it in ArgueFlow Vault, and we'll call it evidence. Like we don't actually handle, and like I use the voting system for that. So it's like if people
what I'm saying is you don't have the claim evidence distinction as such involved. Everything's at the same level.
Correct. Yeah. I mean, like I don't know, Vault can easily like handle it though. It's a matter of like adding a param to the request body for creating a card, and then adding a filter, like which we have all the infrastructure to do, and like could ship that feature in like, you know, less than 4 hours. It's really easy for us to add distinctions on cards. We actually already have a lot of filtering like going on, and like a lot of metadata that gets stored. And it's also like, I mean, using PG vector makes life a lot easier for metadata, because when you have PG vector, like it's really easy.
Yeah, I can join with the metadata, I guess.
Yeah, for us, it's like really hard. And I think, you know, a lot of people are talking about PG vector, like obviously like Neon just did a huge series A and like they're shilling PG vector. It makes me a little bit upset because I mean, the data shows doesn't scale, to be honest. I would like to use PG vector myself. If PG vector scaled, I'd use it. But like Vault is solving a lot of these like metadata problems on the code level, and I'm somewhat attached to it.
You're also fair. I try to not attach to that part of the technology. I am attached to Postgres a lot, I must admit.
We have Postgres.
Yeah, I know. I do think PG vector is also evolving. It's being maintained, and it'll probably get faster with time.
I mean, I think it will get faster, but I don't think it's going to get as fast as Qdra or like Pinecone or Weavy.
Possible. I don't have a horse in that race. I really don't care. But
I don't care either. Like if PG vector got as fast as Qdra, it would make my day. But like the reality right now is that I want to create something people can use, and I can't create that on PG vector. So like
I hear you.
In our system,
I haven't dealt with your scale of data, right?
Yeah, like all I'm trying to, I guess, assert is that like our system like scales well, and I think that like engineering labs put a lot of effort to it. And I'm not married to like our way of handling evidence or like data. I actually like it's really immaterial for me. Like I think the like Vault, like the URL I sent is meant for the competitive debate community, and that's obviously like one audience that might want it. I think it's very true that there might be another audience, people that don't want the competitive debate community's like demo of the product. It's really like the URL sharing is really like meant to be a demo, right? Like it's not, you know, like what I really want is to like replace the parser we have for competitive debate with claim miner, like for your use case, and see if we can get, Vault to like store your data that claim miner is parsing, and then make it accessible on a different URL and maybe like a URL, a UI that's branded differently.
The need that I have is multiple, a kind of fractal decomposition of the document, and that is probably more than a few hours. And I got your point that it may not be necessary, but I have a few very long documents now. Maybe, and there I'm thinking also, maybe I made a mistake by cutting at the paragraph level. I'm really, you're helping me rethink stuff, and thanks for that. In that, maybe I should take things of a certain length, like, 1,000 characters, whatever, and cut the document. Obviously, prefer paragraph or sentence boundaries if they exist, but if they don't, mash, instead of saying exclude short paragraphs, mash them together and have the system deal with a mash. I'm not, again, I'm experimenting with that. I don't have a strong answer, but I want us to be able to actually read. Yeah, go ahead.
I think that you can do most of that like in a Jupyter notebook. I think that if you're doing it like in a Jupyter notebook, then it's really easy to plug into Vault. Like the fractal decomposition of the text and like creating that data, I don't really think you're gonna have to add metadata to Postgres to like handle these different levels of queries you have. And then I think that you should add like Qdrint's abstraction for a table is called a collection. So then I think that you should add different Qdrint collections that store the different tiers, the different layers of the embedding, and you can relate those. So like it's really annoying to have relations in Qdrint, but you can do it. And while I don't think that's it's definitely not like a one-day task, but I definitely think it's less than a week. Like it might take 8 to 24 hours of man work, or like man hours to implement that on top of Vault. Once you have it ready, like in a Jupyter notebook, for like what you want to do on the parsing level.
Yeah, Jupyter is not an option because this is an end user tool, not a programmer tool. But
I'm trying to propose that like Vault would be the end user tool. So like you would use Jupyter to like tune the parser and like the tiering levels of like parsing, and then the end user would end up interfacing like with instead of interfacing like I'm proposing that like claim miner I think should exist more narrowly. Sorry, I don't. Yeah, I'm biased here, obviously, but I'm proposing that like claim miner should not really exist as like an entire system with an API. It should really exist as a parser, and then Vault can be like Vault server, that the GitHub repository could then be the API that users interact with to get the data. Because like I'm definitely attached to Vault server. Like there's been a lot of work already to like make sure it scales. A lot of like the edge bugs have been like caught. Like the UI, I don't think it's going to fit what you want to do with claim miner. So I think you're going to need a different client. But it's very well documented. Like all the routes are documented for Vault server and everything too. So it's easy to build like new clients. And I think that it would make, I don't know, maybe you're not like a Jamstack. Like maybe Vault, like separate client server is not something that you're interested in at all. But I think it makes more sense to do that.
Listen, I mean, I'm rebuilding my server. I'm not opposed to using Vault as a service. I'm not religious. I'm not attached to my code that I did in claim miner. I am attached to the use cases, of course. And I'm thinking, what is it that makes easy? What is it that makes difficult? I don't think that putting all my metadata in Vault makes sense, to be honest, because there's a lot in the claim structure that if I have to do it with just, I have a few tags, filters in the Vault metadata that I don't control, I don't know that that'll work. But if I'm saying, hey, I can put some layers in Vault and some layers in my own database, I'm not opposed to it. Of course,
I was thinking that you would manage Vault yourself. Like I was not thinking of using Vault as a service. I thought that you would host Vault yourself.
That's a possibility.
That's a possibility. I was definitely not assuming that you would want to use our hosted version of Vault. That's probably a terrible idea. I was definitely
Fair
thinking
enough.
that. Yeah,
Fair enough.
I can't even afford that probably, but I was more thinking that I don't know. I think I would like to
that
help
makes
you like
sense.
self-host
So
it.
didn't think that far, but I wasn't thinking about hosting. But I mean, okay, but there's a difference between I'll host and I'll change the schema, right?
Well,
That means
I'm saying that we'll work with you to change the schema. So like it's like we want you to be able to host it for like your use case. So, and we'll work with you. Like if you have things that you need to do so that you can host it and it works for your use case, we'd like to work with you to develop those things. That way you can use it because it benefits the whole world.
Ecosystem. Yeah, that makes sense.
So yeah,
That
it
makes
makes
sense.
more sense for like us to like try because everyone's trying to build these things. Like people have these really dumb, I don't mean to be offensive. People are building like document answering things that I think are very dumb, where they're just throwing excerpts from the document in the context window and like thinking it works well. And I really think like people are not. I think that there's like a lot of room here to like help accelerate the development of these tools by
Yep.
making Vault work for more arbitrary use cases. And I think like that's a matter of like getting a better config for it and like making it more dynamic so you can add the things that you're talking about adding. And what I'm really saying is that I'd like to like work with you on Vault server, like on that GitHub repository to make it work for your use case. I'm not saying that I want you to use it as like a service we host because that's probably not viable.
I understand. Definitely we're thinking about. I'm not opposed to it. As I said, it's not my attachment is not to a code base. My attachment is to so okay, I'll think about it. I'll have to look at your schema.
Yeah, I mean it's documented, right? Like I'm also
Yeah.
like if there's anything that's not documented that you would like, I'm happy to like we're happy to provide it. But like the whole like the whole scheme, if you should be able to clone the repository, like start up start up the Docker Compose like services, and then look at dbeaver, or I use dbeaver. But
can it work without Docker? I hate using Docker.
Yeah, it can. So
Good.
if you just want to use like the PostgreSQL CLI to start your database locally, then you can also just do that. It's the Docker is just a convenient way to set up the services it needs, but you can also do it without Docker.
Good. Now I'll experiment. I'm in vacation next week, so I won't experiment this week, but I'll definitely look at my options. I want to spend time with you, by the way, looking at the agent sourcing aspect.
Yeah.
Not today, but because that's not for the same purpose, but that's something I care about deeply. But that's not in the CDL. Well, which hat am I wearing now? CDL hat or SL hat or my own hat, the Conversance hat. It's difficult to, the needs are not the same. So certainly I could see a path for using this in for Society Library.
Yeah, I mean, like, yeah, I have no idea. I don't know anything about Society Library, obviously. So I have no clue.
Yeah, I'm also thinking the pros and cons. But I see what you're proposing in terms of finding I think when you say you've added a big layer over quadrants, the main layer you've added, if I understand well, is doing the collision detection at the kind of front-ending the collision detection. Am I right?
I mean, I wouldn't say that's the main work. That's probably one of the easier things we did. The hard part of what we did is putting the vectors in Qdrant and putting everything else in Postgres and making that work together nicely.
Oh yeah, that was hard. Okay.
Yeah, I mean, like it sounds like it's not that bad, but
It depends. There's many ways of doing it, some of which are hard. Did you define an external database in Postgres?
No, we didn't do it like we did it. Yeah, we didn't do it that way. We did it we did it using joins. So like we have it set up so like you make your query. There's a few things that happen. So if you want a filtered query, you first go to Postgres, you ask Postgres for the point IDs that adhere to your filters. Then you tell Qdrant that when it does its cosine similarity search, it can only pick from those point IDs. Then when like that gets returned, then Qdrant returns to you some set of point IDs. We make another query to Postgres to join the data needed for all the claims, like all the data, all the metadata to the point IDs. It's kind of like in the best case scenario, a 3-step process. We have it down to like 2 when you don't have filters. It's like when you have no filters, then we go to Qdrant first without filters. And so Qdrant has enough information to handle like basic privacy. So if you have, so Qdrant, we have enough in Qdrant so that way we can avoid Postgres if you don't have filters. And that gets down to 1 Postgres query, 1 Qdrant query. And you know, you could do.
I understand perfectly how that's non-trivial. And is the Qdrant query done from Postgres?
No, it's done from the Rust server.
The Rust server. Wouldn't it be easier if you could call it from Postgres and do the join in Postgres?
It would be easier. We'd have less control over it. And you know, it would be, yeah, it's like an optimization that I'd love to make. Like, you know, that's part of why I want to work on Vault server together and not do as separate things, because if that, like, you know, we have not been able to get that to work, most of the time limitations, like wanting to ship, you know, complete things.
I understand.
Like that.
I understand totally. Yeah. I've been looking at options. One of them is, you know, that Elasticsearch now has vector database. I don't know if you timed Elasticsearch compared to Qdrant.
No, we know Elasticsearch has it. Dens has a lot of time using Elasticsearch. I didn't use Elasticsearch because it's harder to self-host.
But the reason I mentioned Elasticsearch is that you can use Elasticsearch as an external database there's a database adapter in Postgres for Elasticsearch. So in theory, you could do the internal join that way.
Yeah, if there's a way to make, but like I didn't know about that. So this is part of like the stuff that could be really good about collaborating. Because if we add more minds to it, I think we'll end up creating something that's a lot more useful for like a wide variety of use cases.
Right. Because
we'll make something better.
I'm sure. The that would definitely be worth spending time on.
Yeah, like it'd be really worth it. And like you can write regression tests against the existing system to like make sure it works, which, you know, helps.
Yes, I understand. Okay, so it's a whole conversation, but I don't think it's a CDL conversation anymore. I think we can.
Yeah, I agree. So
maybe let's take a few minutes after this. Anything else from Bentley or Michael about what you've seen? Sorry, we've been. Okay. Well, we're both open source and feel free to have a look and have questions.
Yeah, thanks both of you for presenting. It's amazing. And Nick, good luck with the launch. You said what, 2 weeks?
No, Monday.
Monday. So, okay. Yes. Yeah, so definitely good luck.
Thank you. Much appreciated.